last time? F of x minus f of a over
Root x,
over
x minus a.
over
X minus A.
X
nothing.
minus
It doesn't work. That only works for f prime of a.
Oh.
Do you see my point? Yeah, I'll wait. I think I had a couple choices for my definition of f prime and value, a very specific input like a, but I only had one definition for the derivative function. And so if I'm looking at f prime of x, I think I have no choice. I'm kind of stuck. I have to take a peek at the limit as h goes to 0 of this particular Newton's quotient. Do you guys see my point?
Yes.
I want a yes or no answer. For some of the functions f in the homework last night, was it difficult or complex or just busy work to come up with a derivative function?
Busy work.
Yeah, I think there are a few that are quite busy. So maybe what we can do today is develop a lot of shortcuts for differentiating a variety type of functions. You're right, not on this test because I don't test you in the pre-state material. What do you think you could say? About this. If I were to differentiate with respect to x a constant, what should I get?
0.
Why? You don't like me asking that question.
Because the slope of 2, for instance, is always going to be 0.
Because slope of y equals 2 is always equal to 0. Because slope of y equals any constant c is the slope of a horizontal line, period. It should be 0. But you know what? You're correct. Let's prove it. And to prove it, let's go ahead and assume I got a function f whose output is a constant. Using my definition of the derivative function, let's find f prime of x. I think f prime of x is nothing more than a limit as h goes to 0 of my f of x plus h minus f of x all over h. But this is just simply the limit as h approaches 0 of the difference of two things all over h. Let's talk about those things. See how fast you are. What's f of 7? C. What's f of 3?
C.
C. What's f of this thing?
C.
What's f of that thing?
C.
But I think c minus c is just
0.
0, and 0 divided by h is just
0.
0, but the limit of 0 is h does anything a Darwin pleases is 0. I think we just proved derivative function has to be the 0 function. Let's see what you and I can say about the derivative with respect to x of, I don't know, how about some constant c times some function f? This time around, if you guys don't mind, I don't want to sit here and take a break and discuss this intuitively. Let me just crank out what it has to be. I think if I'm going to differentiate with respect to x some constant times some function f, you've added x, then looking at my difference, or the limit I should say, of a difference quotient, I think it's this. I want a yes or no answer. Do you agree so far? No tricks.
Yes.
I heard that. Good. And so out of the two terms upstairs in numerator position, I can pull out a common factor c. But in terms of my limit, this constant c has nothing to do whatsoever with h. So if you guys don't mind, I'll simply pull it out. Now I just want a yes or no answer. Do you guys recognize this garbage? That's just specific. It's just f prime of x, bottom line. When it comes to constant coefficients, you get to pull them out of the differentiation process. The derivative with respect to x and some constant times some function in x is nothing more than that constant times well, the derivative of f with respect to x. Let's see what happens when you and I differentiate with respect to x the sum of two functions. Oh shoot, you guys, this isn't Math 42, it's not Math 16, this is not an applied calculus course. This is calculus for science and engineers and mathematicians. So here too, I'm gonna verify what I'm gonna say. I will derive this out of thin air, so that you have to believe what I'm saying is true. So to differentiate with respect to x, the sum of two functions, I think what I really have is a limit as h goes to 0 of my new function called f plus g valued at x plus h, minus that new function valued at x, all over h. But because of your math D definition of the sum of two functions, I think the first term upstairs can be broken up into the sum of these two terms. Because the same darn definition back in Math D, I think you and I can break up the last term into the sum of these two terms. Bless you. I think, number one, since everything upstairs represents a real number output, I can exploit the law of commutativity for addition in a real number system and interchange these two terms. And then I can split it up into two different limits. I think the first one's this. I think the second one is this. Anybody willing to stick their neck out and tell me the name for the first limit? Second limit? So what we're really saying is this, you guys. To differentiate the sum of two functions, it's just the sum of their individual derivatives. Please don't worry about this. Life isn't always going to be this easy. I promise when it comes to multiplication and division, this is not true. It's not just direct distribution. But I have to confess, subtraction would be just as easily proven. And if you guys think about this just for a brief minute, I think what I have on the board is really abstract. This is the only specific function I've differentiated with my shortcut rules. I better grab some others. These are just simply more generalized rules. So what about this? F of x is equal to x to the n power n is some natural number. Let's see how we can find the first derivative function. Because that would be nothing more than this, right? Remember, I'm the person in this room to attack. Oh, you're right, I don't have him there yet. Good point. So I guess my function f specifically is raising the input to the nth power. So translating, I guess that means I got x plus h to the n minus x to the n, all over h. Do you guys mind if I expand that binomial? Shoot, what does that look like? It looks like a
X to the n.
n chosen 0 at a time times x to the n, oh, I heard 1 plus n chosen 1 at a time times x to the n minus 1 times h to the first, plus n chosen 2 at a time times x to the n minus 2 times h squared, plus n chosen 3 at a time times x to the n minus 3 times h thrice.
That made no sense to me.
Really? You don't like the notation? The binomial theorem? You remember the binomial theorem?
Yeah.
So it's like an upside down cyclops.
Really? Okay, so my notation might be a little bit different here, you guys. Check this out. I mean, my n shows in 0 to time, you might have written this way. Or maybe you wrote it this way. Yeah, Christian. Okay. Which in the end is nothing more than n factorial over 0 factorial times n minus 0 factorial. But 0 factorial is defined to be 1. So I get n factorial over n factorial, which is
1.
oh, we just valued the first one. So I guess this is the limit. As h goes to 0 of 1 times x to the n plus n chosen 1 at a time is really just n. Oh, you guys didn't miss some terms? I never finished, did I? Oh, there's a huge plus, dot, 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 down to an n chosen n at a time times h to the n power. And I've even forgot my very last term, which is a minus x to the n, all over h.
Wow, I don't know what any of that means.
Aren't you happy?
Oh, yeah.
I thought you would be.
Not the damn thing, guys.
Oh, you know what? Something really nice happens. Look, the first and last terms, they completely cancel each other out. Now, I want a yes or no answer. If you neglect this first term, don't look at it. Is it not true that all the remaining terms I have listed on the inkboard have at least 2 factors of h?
Yes.
And if you're in agreement with that, what I want you to do is factor an h out of everything you see upstairs and cancel the h downstairs. Now, from the first term I neglected, this h canceled that h, and I think I'm merely left with the limit. As h goes to 0 of that very first term, which is n times x to the n minus 1, plus a bunch of other terms.
Is that a mathematical expression?
Absolutely, it is now, as I said. Each of which
How does 0 in it?
has at least 1 factor of h. Meaning, now when I take this limit, everything in the second group and a whole bunch of terms goes to, and I'm merely left with the limit of this thing that has nothing to do with h, so it's just going to be that thing. This is so important, I give it a name. I call it my power rule for differentiation. My first technique for differentiating a sophisticated type of function. So from now on, to differentiate with respect to x, something of the form x to the power, I simply get x times n to the n times x to the n minus 1 power. I'll say that differently. I get to wrap my fingers around the n, pull down to the level of everything else by multiplication, and reduce the exponent by 1. Yeah, Steve, this is exactly what this says when I read it from left to right. It says, to differentiate x to the n, you put your fingers around the n, you pull it down to the level of everything else by multiplication, and you reduce the exponent by 1. As a matter of fact, from here on out, you guys, n doesn't even have to be a natural number. It could be any real number. Even with complex numbers, this differentiation rule still holds, and it sounds like you're making things more complex. But even at a certain level of mathematics, particularly differential equations, your life's a lot easier when you force complex numbers to be in there. You'll be amazed at how much easier life is. And so even here at Sierra College, when you take a typical Math 33 course, we're going to sometimes allow that to be a complex number. It literally makes the differentiation process smooth. It's really slow stuff. I can't justify it without a bit of Math 31 though. So it's going to have to wait a little bit. Can I get rid of this, you guys? You want to attack me? Yes, please. Oh, you want to go.
I want to attack it, but can you not get rid of it?
Yes. Everybody, you okay? No, you're not okay, because it's way too much work. This is what we did last night. What do you want to do now? Yes, skip all this garbage. Because I think to differentiate, all I have to do is this, proclaim that the derivative difference of sum of two functions is the difference of sum of the derivatives. And even when it comes to this first term, I can pull out that coefficient too, because jeepers, we already proved that we can pull out those constant coefficients. Let's just dive in and differentiate directly with our shortcut rules. Power rule. You wrap your fingers around the 2, you pull it down to the level of everything else by multiplication, and reduce your exponent by 1. Next, differentiating x to the first power. Bring the 1 down, reduce your exponent by 1, you get x to the 0 power, that's just 1. Differentiate a constant, it just goes to 0. Look at that, in one full swoop. No more limits and difference quotients. The derivative is that immediate with these shortcuts. You have to sit there and be impressed with how much work we saved. If you don't go back to that definition.
And so this is not allowed on the test?
Not on tomorrow, Saturday, Tuesday, Wednesday.
But you can check your answer using your.
Absolutely. Yes.
Can you show me that one?
Yes. You mean the process? The process is this. When I got a series of power terms, I just simply wrap my fingers around the exponent, bring down to the level of everything else by multiplication. So I get 2 times 2. But then I reduce that exponent 2 by 1 to get. And next, to differentiate 3 to the x, or x to the first power. Here too, bring the exponent 1 down to everything else by multiplication, but when I reduce the exponent by 1, don't I get x to 0 power? But that's just simply 4x minus 3. Ryan?
Just to kind of clarify that I'm understanding it right. Like, say the original problem was 2x to the third power, would it be like 6x to the second power?
It would.
Okay.
I agree completely.
And then could you read with me and say what happens with 5? We just canceled that out because it doesn't have it?
I don't know. There's a couple different ways you can look at it. Here's one way. We already proved the derivative of a constant all by itself is 0.
Oh, okay.
But if you don't like the way I'm saying that, do this. Is this true? Then is this true? But now if you bring the exponent down, you get 0 times 5 times x to the negative 1, it's just going to be 0. So you can still use a power rule if you want to, if you don't want to listen to my first rule over there. There's a lot of different ways you can look at it. Here's another non-rule. When it comes to multiplication and division, yes, your life is not for free. When it comes to division, your life is not for free. Now, I'm sorry, you guys, if I'm not saying any more than that, at least not yet.
So
I don't know if I will tonight or not, depends on how far I get.
when's the appropriate time to use d over dx for your derivative?
You're not going to yell at me?
No.
Whatever you want.
Whatever you want?
Whenever you
So
want.
when would be the appropriate time to just use a triangle?
That's never appropriate.
It's never
Because a
appropriate.
triangle doesn't represent the differentiated process. And when you say triangle, it's not really a triangle, it's the uppercase Greek letter D for delta.
Ah,
Or delta for D. And we typically use that for a small change.
okay,
Which I think is completely different.
okay.
For your proof of the
Yes.
power rule,
Yes.
does it necessarily follow that if, like, at h approaches 0, we get that? Does that necessarily follow the limit as h approaches anything?
No, I think that would be inappropriate. I specifically want to see what happens as h approaches 0. Otherwise, I don't really get the slope of the secant lines getting closer and closer to the slope of the tangent lines. It
Oh,
has to
got
be
it.
as h goes to 0.
Oh,
So those
okay.
2 points merge on each other.
Okay, but it's always going to be h approaches 0.
Yes.
Yeah, okay.
Well, Nabil, I see some authors do this.
Oh,
In here. But that it doesn't amount to just giving a substitution, calling h something different, calling it
Yeah,
delta
okay.
x. I mean,
okay, gotcha.
I can see why some authors flavor is in this direction, because they want to think of it as a small change in the x direction.
Yeah, okay.
It means-
But it's the same thing.
But it always goes to 0 for this difference quotient.
Okay.
I think what I can do is differentiating 1 gives me 0. Differentiating negative x gives me, no, you should say nothing.
0.
Because to differentiate the ratio of 2 functions, I don't just dive in upstairs and downstairs and differentiate. So I've got no technique tonight, at least not yet, for differentiating such a ratio. I have to use my math D skills first to rewrite the single fraction into the sum of different fractions. Like, for example, no calculus. Take a mathematical axis here. Isn't the first fraction just simply going to reduce to this? My second one reduces to this. My third one reduces to this. And I think I have the mathematical legal right, just using my math D skills, no calculus yet, to simply rewrite each of the terms as a power term. Let's give it a shot. First term clearly is having x raised to this power, no big deal. What about the second term? What about the third term? Now that I've got the sum of 3 power terms, I have the mathematical legal right to dive in and simply use the power rule for differentiation. Let's do it. I said, let's do it.
2x minus 1 half negative half negative
X to the negative 3.
Very nice. Are you guys happy with my answer?
Messy.
Well, you could write it like
How do you know that?
because you could make that 1 over.
Why would you want to do that?
I'm just saying you could, you don't have to.
It looks nicer that way.
See, I'm trying to force you to do just that, because I think mathematical etiquette suggests you started off with a function using radical notation. We may have converted the fraction exponentiation to make calculus easy, but I think at the end we really do need, by mathematical etiquette, to rewrite in terms of radical notation. Do you guys agree? If you agree, then let's rewrite. I think f prime of x could be rewritten as a 2x. Is that minus 1 over 2 root x? Is that a minus 1 over 2x root x? Ah, shoot. More mathematical etiquette. I guess the original function was posed in terms of as a single fraction. Let me